Okay, the exciting chain rule 3.4. This rule is going to help us differentiate whenever we have the composition of two or more functions. So let's look at this function that is composed out of two. I don't know if you can see that. The first function that I'm using, or the outer function, the function that is outside, is the function of square root. And then I'm using a quadratic function inside of it. So there are two functions going on in here. Okay, so I can redefine what's inside of the square root, and I can call it a function u. So if I have to rewrite this function in terms of u, it would be simply the square root of u, where u would be x squared plus 1. So I have the composition of two functions where the function inside is x squared plus 1, and the function outside is taking the square root of that. So I have the composition. Let me define f at the square root, and u, or a function of x that I'm going to call g. So the composition of f of g, it would be the square root of x squared plus 1. The only thing you have to keep track here is in the order in which it happens. If the input is x, then g of x is happening first, and then the function f is happening second. But we're going to refer to this function here as the outer one, because it's the one that is most to the outside, and then this one is going to be the inner function. So taking the derivative of a function that is the composition of two functions will imply to do two things. First, take the derivative of the function that is on the outside of the outer function, evaluated at the inner function, times the derivative of the inner function. I'm going to use example 1 to illustrate this rule. Okay, so my function f is square root of x, and my function g is x squared plus 1. Since sorry, this shouldn't have been here. Since I'm defining my function f as the composition of f of g, then the derivative of such function will be given by the rule f prime of g of x times the derivative of the inside function, which is g prime of x. So what is the derivative of f if f is simply the square root of x? Let's remember the power rule. This would be x to the 1/2, so the derivative will be 1/2 of x to the negative 1/2. Okay, so that's what I'm going to write here, except that it's not simply x, I have g of x. So this will be 1/2 of g of x to the negative 1/2. Times the derivative of g. In here I'm going to apply the rule, and this is 2x. Derivative of 1 is 0, so that's just 2x. Now I'm just going to make it beautiful. So I replace g of x with x squared plus 1. The 2's cancel out, and I'm going to rewrite the exponent negative 1/2 as the reciprocal of the square root of x squared plus 1. Maybe you didn't like the notation that you saw before, so another way of doing it, it's pretty much using the same idea, but just a different notation. You're going to let the function u be the inside function, which is in this case x squared plus 1. You're going to redefine the function as dependent on u, which is just the square root of u. And then the derivative will be given by the derivative respect to u times the derivative of u respect to x, because u depends on x and f depends on u. So that's why it's called a chain rule, because it's like a chain. So the derivative that I'm looking for is given by the derivative of y respect to u, which is 1/2 u to the negative 1/2 times the derivative of u respect to x. So I'm gonna take the derivative here, which is still 2x. And then in the next step, I'm gonna replace instead of u, I'm going to have x. So I'm sorry, instead of u, I'm going to have the function that depends on x. So u is x squared plus 1 to the negative 1/2 times 2x. And again, the same thing happens, the 2's cross out, so I'm going to have x over square root of x squared plus 1. So if you like making the transition to naming this function u and use the chain rule this way, that will be fine as well. Here in example 2, we have 2 exercises, and I want you to compare them. In here, the order matters. X is being squared first, and then I'm going to take the sign of that value, and in here I'm taking the sign of x first, and then I'm squaring it. Although it doesn't seem like it, remember that this is the way of writing sign of x to the second power, which means sign of x times sign of x. So in here, the square is the inside function and the sign is the outer function, and in here the sign function is the inner function and the square is the outer function.